Okay, now let us start our today's lecture. Today we will be going to discuss the op-amp is act as inverting amplifier. What is meant by the inverting amplifier? When we apply the any one signal to the amplifier. If the signal is a positive, we can getting the output is the negative. Or if the signal is negative and we can getting the output is a positive, that means the inversion is done. That's why this is called the inverting amplifier. Here the power supply or sinusoidal signal V1 is connected to the inverting terminal through the R1 resistance. Pin number 3 is connected to the ground. Pin number 3 is connected to the ground, and feedback is connected from output pin number 6 to the pin number 2 through the R2 resistance. Here our output voltage is equal to what? It is minus R2 divided by R1 into supply voltage, or we also say that V0 is equal to minus Rf divided by R1 multiplied by V input. What is the formula? It is the V0 is equal to minus Rf divided by R1 multiplied by V in. How it is? So let us deriving the expression. Okay, as in this diagram, here pin number 2 which is connected to the power supply, pin number 3 is connected to the ground, pin number 7 is required plus VCC, pin number 4 is required minus VCC, feedback is connected to the R2 terminal. Now in the inverting amplifier, according to the virtual ground concept, the VID is equal to 0. VID, that means the differential voltage V1 and V2 minus V1 is equal to 0. Okay, this is derived from the virtual ground concept. According to that, V1 is equal to V2. This is the first one equation. Here V2 is the pin number 3 is connected to the ground, so that's why the ground potential is equal to 0. This is the third one equation. And the potential across V1, this is the due to the output voltage V0. This is due to the output voltage V0. That means the voltage drop across the R1 divided by R1 plus R2 multiplied by V0. This is the first one formula, R1 divided by R1 plus R2 multiplied by output, plus this is the voltage developed due to the output voltage and the voltage developed due to the input voltage also. Here R2 divided by R1 plus R2 multiplied by V in, then V1 is equal to R1 divided by R1 plus R2 into V output plus V2 divided R2 divided by R1 plus R2 into V in. Now here equation 1, 2, 3 is a compare with each other. After the comparison, V0 V1 is equal to V0. Then with this 0 is put into there. Okay, then what happened? This output is going to the at that place, and here after that it is R1 divided by R1 plus R2 multiplied by output voltage is equal to minus R2 divided by R1 plus R2 into V input. Now this V output is placed here and V input is going to, okay, now this V output is the same place and this term is going to at that place. What happen? This R2 get cancel, R1 plus R2 is get cancel, and R minus R2 divided by R1 is a present, multiply by input voltage. Here V output is equal to minus R2 divided by R1 and multiply by V in. Okay, so output voltage is equal to minus M multiplied by V in. This is the gain formula of inverting amplifier. Let us take the one example. If the input voltage is the 5 volt, if the input voltage is the 5 volt, our R2 it is the 15 kilo ohm, R1 is the 3 kilo ohm, and we want to find out the output voltage. So we have the formula output voltage V0 is equal to minus Rf divided by R1 multiplied by VCC or V input. So here Rf is 15k, minus sign is there also, 15k multiply by divided by 3k multiply by input voltage is the 5 volt then 3 divided by 15, it is the 5. So the 5 multiplied by 5, it is the 25 volt, which is negative, which is negative. So this is the example of inverting amplifier. Then another one, we also take the another one example. If we consider here input voltage is 4 volt, input voltage is a 4 volt, here resistance is the 2 kilo ohm, input or feedback resistance is the 24 kilo ohm. Then what is the output voltage? Output voltage is equal to minus RF divided by R1 multiplied by VCC or V input. So here minus RF कितनी है 24 then divided by R1 is the 4 multiply by VCC. Just a minute, what is I want to use this. Okay, here minus 24 divided by 2, it is the minus 12 multiply by 4, answer is minus 36 volt. That means we apply here, we apply 4 volt, we apply the 4 volt, and the due to the gain output voltage is get amplified up to the 36 volt, but output is inverted in form. Why we call the inverting amplifier? Because when we apply the positive waveform to this input side, we can getting the inverted form of the signal to the output side. So that's why this is known as inverting amplifier. And the gain formula is V0 is equal to minus RF divided by R1 multiplied by V input. Okay, this is very simple. Okay, thank you so much.